Hey, let me just take you through a couple of, maybe one, and then let's see how it goes, and then might take you through a couple of genetics word problems using Punnett squares. So what it says here is in guinea pigs, short hair is dominant to long hair, meaning short hair is represented using an uppercase S, and long hair is represented using a lowercase s. So we have to fill the Punnett squares and then answer, answer for these. So let's see. One of the parents, this is the direction or information we're given. One guinea pig is homozygous dominant, and the other pig is homozygous recessive. Now, typically you would put the mother gametes up here, but we don't know who's who, so it doesn't really matter. We'll just put the heterozygous dominant over on this side, and we'll put the homozygous recessive on the vertical side. So that's two lowercase s, two lowercase s's. Now the possibilities of these guys, the possibilities for the offsprings, we can check in just a minute. So for this, we have an uppercase s from here and lowercase s from the other side of the grid. Same over here, we have lowercase s, and then we have lowercase s. Over here, we have an uppercase s, and we have lowercase s. In the last one, we have two lowercase s's. Let's see. We can now that the Punnett square is complete, we can analyze to answer these questions. So the expected number of offsprings that have short hair would either have to be homozygous dominant or heterozygous dominant. And if we look at the Punnett squares, we don't have any homozygous dominance, but we do have heterozygous dominance, and that's 2 out of 4 guinea pigs. So that's the chances, or the frequency, is 2 in 4, meaning every time these couples have an offspring, they have 2 in 4 chance of them having short hair, or that's a 50% chance. So 2 in 4 or 50%. Sorry, that was all supposed to have gone up into this box right over here. Let me rewrite that. So that's 2 and 4. Missing my cursor. 2 and 4. Okay. And if you look at the long hair alleles, you'll have to look for cases of homozygous recessive, and that's also 2 and 4. So basically, the possibility for long hair is also 50%. And 4. 2 and 4 here, and 2 and 4 over here as well. 2 and 4 over here as well. Okay. Now, once the parents change and both the guinea pigs are heterozygous for short hair, that means you have to kind of make sure that both parents are heterozygous for the heterozygous for short hair, meaning they have the genes for both long hair and short hair, but they appear phenotypically they're all short hair, because short hair is dominant. Now let's check the possibilities for this. What you get in this case is an uppercase S, and another uppercase S, and then you have an uppercase S. The dominant allele is always written first, and then you have a lowercase s, and you have uppercase s and a lowercase s. And for the last one, I believe you have two lowercase s's. Now check the possibilities and frequencies for this scenario. The short hair, if you look at the short hair, you gotta look at the homozygous dominant as well as the heterozygous dominant, and that will be, so if you are looking at this is short hair, this is also short hair, this also represents short hair. So in this case, the chances of the pigs having, or the frequency of the pigs with short hair is 3 in 4 or 75%, and the only long-haired possibility is 1 in 4, because the long hair will only be expressed if it's a case of homozygous recessiveness. So it's a 1 in 4 chance of the guinea pig having long hair. Now that's a 25% chance. So every time these two parents have offsprings, 75% of the time they will have short hair, and only 25% of the time they will have long hair. Very quickly, moving on to another set of questions. This time we're looking at human parents. So in this case, the trait we're looking at is tongue rolling, and tongue rolling is dominant over non-rolling. So it says over here, a man who's a non-roller. So the father's phenotype is he is a non-roller. He's a non-roller, and his genotype is tricky because it's a dominant gene that causes one to be a roller. Sorry, his father is a tongue roller. I made that mistake over here, so he's a roller. Sorry, again, the father is a non-roller. I was reading something else. Alright, the father is a non-roller. And because the father is a non-roller, it means that his genotype can only be homozygous recessive. Because if he had a roller gene, he would not be able to roll his tongue. He would be able to roll his tongue. The mother's phenotype is she's a tongue roller. So mother's phenotype is she is a roller, and her genotype would be she's heterozygous, meaning she has an uppercase R and she has a lowercase r. Now, if you're to kind of complete this Punnett square on those information given to us, we'll put the mother, sorry about that, so we are going to scribble. So the mother is, I realize I can only do, I have to draw them non-stop. So here's my R, and the mother also has a lowercase r, meaning she is, that looks like a V, but I want you to imagine this is an R. And the father is a lowercase r and lowercase r. Okay, that looks better. Now, once they have kids, sorry about that again, gotta do that again. So remember, I have to do this in one go. and there is also a non-rolling gene right there. For the second square, you have lowercase r, and you have a lowercase r. Much better. Sorry, I lost my other r. So here it is. For this scenario, you have an uppercase R, and you have a lowercase r, which I'm getting better at. And for the last scenario, you have one lowercase r and another lowercase r. Now, what is the probability of this couple having a child who is a tongue roller? Now, the tongue rolling gene is dominant, meaning anytime the uppercase R appears, the child would be a tongue roller. So if you look at that in the 4 possibilities that you had, sorry, I lost another R over here. Let me just complete that. So of all the 4 possibilities that you have, I don't know why it keeps disappearing. Let me try one more time. Otherwise, I want you to imagine there's an R here. Okay, there you go. So here is a child. So out of the 4 offsprings, that 2 would be tongue rollers. Now, if they're tongue rollers, that means out of the 4, 2 would be tongue rollers, meaning 50% chance that every time this couple has a child, there would be a tongue roller, and that also makes it possible that every time they have a child, it's a 50% chance that they are non-rollers. Hopefully that helps. Thank you.